Okay, am I audible?
Yes, sir.
Okay, thank you. So here we are considering the discharge equation. Discharge equal to area into velocity. Okay. So in place of velocity, in one equation we have used Manning's equation that we have given equation number one, and one equation we have used Sedgwick's equation. Okay. So discharge equal to area into velocity. For Manning's equation, we know velocity equal to 1 by n r to the power 2 by 3 sb to the power half. Okay, so we have substitute here and we have put equation number 1. Okay, similarly for velocity we have used Sedgwick's equation. V equal to c root over r is nothing but your hydraulic radius, that is your area by weighted perimeter multiplied by bed slope. Okay, so we have substitute here and mark as equation number 2. If you see here in equation number 1, if you see in equation number 1, we can write q divided by, this is as b to the power half, that is slope. Okay, slope of the channel will be constant. Okay, if we consider Sedgwick's or Manning's, it doesn't matter, our slope will be same. So what will be left out, that is area multiplied by r to the power 2 by 3 divided by n. Okay, so you can write this from equation number 1. So equation 1 we can write in this form. From equation 1 we can write this form, that is q by root over, as to the power half to the power half, we can write root over s. Okay, root over sb is equal to a multiplied by r to the power 2 by 3 divided by n. Okay, similarly for equation number 2, from 2 equation number 2 we can also write q divided by root over sb is equal to area multiplied by c root over r. Okay, so from Manning's equation we can write this expression. Okay, from Sedgwick's equation we can write this expression. Okay, so our left hand side is same. Okay, you see in both the case our left hand side is same, so you can write, from there you can write this expression. Okay, that is k. So q by root over s is nothing but, that is your bed slope. Okay. So we can, if we find out k, then if we can find out k, then we can also find out the Manning's roughness coefficient from this equation. Okay, or from that same k we can also find out the series constant. Okay, we can also find out the series constant from this equation. Okay, so k is nothing but your discharge divided by root over bed slope. This is k. Okay, so next we are going to solve numericals related to our Manning's and series constant. Okay, so I request you to take a pen and paper to solve the numericals. Okay, So here is our first numerical. Find the discharge through a rectangular channel of width 2 meter having a bed slope of 4 in 8,000. The depth of flow is 1.5 meter. Okay, what is given? We need to find out the discharge. Okay, we need to find out the discharge. Then they have said the channel is rectangular channel. Okay, that is given. Channel is rectangular channel. And what they have given, the width of the channel, if we consider the width as b, width of the channel is given 2 meter. Okay, having a bed slope as b is given 4 in 8,000. Okay, 4 by 8,000. Okay, then they have given depth of flow, that is y value. They have given how much? 1.5 meter. Okay, okay, and they have given Manning's constant or Manning's roughness coefficient 0.012. Okay, these are the given data. Okay, with the help of this given data, we need to calculate the discharge through this rectangular channel. Okay, so we all know to find out discharge, we can directly find out Q equal to area multiplied by velocity. Okay, so area we need to find out. Area we all know for a rectangular channel, it is width of the channel multiplied by depth of flow. So width of the channel is already given, that is 2 meter. Y is also given 1.5 meter. So we can find out the area, no problem. Okay, and to find out velocity, next thing we need to find out velocity. Okay, to find out discharge, we have first we need to find out velocity, then we have to multiply it with area, we will get the discharge. Okay, so for velocity we have two equations, one is Sage's, one is Manning's. So as in the question we have Manning's roughness coefficient, so that is why we are going to use Manning's equation, 1 by n r to the power 2 by 3 s b to the power half. Okay, then you find out velocity. So here you can see area is b into y, 2 into 1.5, we got 3 meters square. Okay, then we need to find out velocity. To find out velocity, we have used Manning's equation because in the question Manning's roughness coefficient is given. Okay, so bed slope here in this velocity equation, bed slope is given, that is 4 by 8,000. Okay, so n is also given, that is 0.012. Okay, what is not there? That is r, that is hydraulic radius. R is equal to nothing but area by weighted perimeter. So area also we have already calculated, that is 3 meters square. So what we need to calculate now, that is your weighted perimeter. Okay, so we all know weighted perimeter of a rectangular channel. You can see this diagram here. So weighted perimeter means till the level of water. So perimeter till the level of water. Okay, not the whole channel. Okay, so we have to add y, then we have to add the width of the channel, then again we have to add depth of flow, that is y. Okay, so that is why weighted perimeter is b plus twice y for a rectangular channel. Okay, so we have add 2, b is equal to 2 meter is already given. In addition to that, 2 multiplied by y, that is we have add 2 times of y, so that is why we have taken twice y. Okay, 2 multiplied by 1.5, so weighted perimeter you are going to get is 5 meter. Okay, then you substitute in this equation and find out the velocity and see you get the discharge is almost 4 meter cube per second. Okay, use your calculator and try to find out this result for discharge. Okay, so here you see, or in Manning's equation, n value is already given. R is A by P and SB equal to 4 by 8000. Okay, you can write 4 by 8000, or you can also write 1 by 2000. It's up to you. Okay, 4 by 8000, or you can write 1 by 2000. So area is 3 meter square and weighted perimeter we got 5. Okay, substitute here, use your calculator, find out the velocity, and then you multiply it with area and find out the distance. You will get approximately 4 meter cube per second. Okay, so we are going to proceed to the next numerical. Okay, second numerical, find this slope of the bed. Okay, so this time we need to find out bed slope, SB. Okay, we need to find out the bed slope. Okay, Then what is given? Again, it is given as a rectangular channel. Okay. So first it says we need to find out the bed slope, or you can say slope of the channel of a rectangular channel. Okay. This next second thing is given is rectangular channel. Then what is given? The width of the channel is 2 meter. That is also given. Okay. So here it is not visible. Is nothing but when water depth is 2 meter. Okay. Water depth is also given, that is 2 meter. Okay. And this is end. Okay. Find the slope of the bed of a rectangular channel of width 2 meter when the water depth is 2 meter and the rate of flow is nothing but your discharge. Okay. Is given as 20 meter cube per second, and we have Sage's constant, that is equal to 50. C equal to 50. Okay. So what is given? Width of the channel is given. The channel is rectangular channel. Width of the channel is given 2 meter. Depth of flow is also given 2 meter. Discharge is also given 20 meter cube per second, and Sage's constant is also given 50 meter. Sorry, 50. We don't have any unit for Sage's constant. Okay, it's 50. So again, we need to find out the area. Again, we need to find out the area like the previous case. Area equal to b into y, as in the question is given it is a rectangular channel. So area is 4 meter square. Okay. So discharge equal to area multiplied by velocity. Okay. Discharge is given this time. Okay. 20 meter cube per second. Area we have already calculated, is 4. In velocity, as Sage's constant is given, so we are going to use Sage's equation. Okay. We are going to use Sage's equation as Sage's constant is given. So we are going to use Sage's constant. Sage's constant multiplied by R into S. So if you see in this question, SB we need to calculate. Okay. We need to find out SB, that is bed slope. C is given 50, R, then we need to find out R. R equal to area by weighted perimeter. Okay. Area we have already calculated, 4 meter square. Then we need to find out the weighted perimeter. Okay. So definitely it will be b plus twice y, as given this channel is rectangular. Okay. So we have calculated the weighted perimeter and found it to be 6 meter. So area will be 4 by 6. Okay. Then you substitute in the value of r as 4 by 6, c equal to 50, and you see you have one equation and one unknown. So you try to find out the slope and see how much you got. Okay. Here you can see r equal to a by b, that's 4 by 6. You can also write 2 by 3. Okay. Then we have calculated velocity. You can directly use those equation, or you can also use, or you can also solve in this way. Okay. No issue. That is q equal to area multiplied by velocity. So velocity equal to q by area. The answer you are going to get the same. Okay. Q by area equal to velocity. So discharge is given 20, area is already we have calculated, that is 4. Okay, so it is 5. Velocity is 5 meter per second. Okay, and then you can use this equation and find out the bed slope. Okay, you will get this value. Okay, try to find out the slope and see if you are getting the same or not. Okay, and if you have any doubts regarding this, you can ask me. Okay, okay. So you write down the question. Find the slope of the bed of a rectangular channel of width is 2 meter, comma, when the water depth is 2 meter and the rate of flow is given as 20 meter cube per second, full stop. Okay, take C equal to 50. So you are getting the value C by 200. So slope you can write C by 200, or you can write 3 in 200. Okay, 3 in 200. Okay, or you can write 1 divided by 200 divided by 3, or this you can also write 1 in 200 divided by 3. Okay, if you divide this, you will get one. How much you are going to get? 300 divided by 3, so 200. We'll get some fraction. Okay, here, so you can write this way also. It's up to you. Okay, or you can simply write 3 by 200 also. So if this is okay, then we will move on to the next numerical. Okay, next numerical. Okay, number 3. So find the discharge. We need to find out the discharge of a trapezoidal channel. So this time our channel section is trapezoidal. Okay, and then given is width is 8 meter, side slope, okay, is 1 horizontal is to 3 vertical. Next, depth of flow is given 2 meter, sorry, 2.4 meter, and the bed slope, that is your SB. Okay, bed slope is given 1 in 4000, and Sages constant is given is 50. Okay, Sages constant is given. So what is given? Trapezoidal channel. Width of the channel is 8 meter. Side slope is 1 horizontal is 3 vertical. Depth of flow is 2.4 meter, and bed slope is given 1 in 4000. Okay, and the last it's given C equal to 50, and we need to find out the discharge. Q equal to what will be the discharge? Okay, So this is your trapezoidal channel. Okay. So what is given here? Side slope is given. Okay. Width of the channel is given 8 meter. Okay. And depth of flow is given 2.4 meter. Now, first of all, we need to find out the area. So to find out the area of a trapezoidal section, we have to do sum of the parallel sides. So in this trapezoidal section, we have two parallel sides. One is your top width of the channel and one is your bottom width of the channel. See, when we consider rectangular channel, the calculation is much simpler than the other channel section because the top width and bottom width in a rectangular channel is same. Okay. Whereas if you consider in trapezoidal channel, your bottom width and top width are not same. Okay. Your top width and bottom width are not same. Okay. So in this case, we have two parallel sides, one your bottom width, that is your B, and one is your top width. So area of a trapezoidal is nothing but sum of the parallel sides divided by 2 multiplied by the vertical distance. That is vertical distance between your top width and bottom width. That is nothing but your depth of flow in this case. Okay. So this is your area expression for trapezoidal section. Bottom width addition top width divided by 2 multiplied by the depth of flow. Okay. So now bottom width is given, that is your 8 meter. Okay. In this question your bottom width is 8 meter. Depth of flow is also given, that is 2.4 meter. We need to find out the top width to calculate area. So first we need to calculate top width. Our first intention is to find out top width. Okay. So to calculate top width is from here to here. Okay. So we have two extra portion than the bottom of the width. This middle part we can say this is a bottom width. Okay, from here to here. Okay. In addition to the bottom width, we have another two portion. That is one here, another one is here. Okay. So first our intention is to find out this portion. Okay. So why it is called Z Y? Okay. Suppose this is our depth of flow from here to here. Okay. And we have considered that is Y. Okay. And side slope is nothing but your 1 is to Z. Okay. Let us see, when we have considered side slope, we have one vertical distance and one horizontal distance. That is, one vertical is equal to Z horizontal. Okay. We have considered, in general, we always considered our side slope is 1 is to Z. Okay. So 1 is to Z. One vertical is to Z horizontal. That means this is your vertical, this is your vertical, and this is your horizontal. This is your Z. Okay. And this is your vertical. We have considered one vertical, Z horizontal. So we can write one vertical is equal to Z horizontal. So now see, for this portion, we have a vertical of Y. Okay. If one vertical is equal to Z horizontal, so what will be the value for Y vertical? It is nothing but your ZY horizontal. Okay. These things you have already studied in third semester. Okay. We are just brushing up. Okay. How to find out this slope. Okay. Or you can say this portion. So that is why, see here, if you see, this is our horizontal distance. Okay. This is our horizontal distance. This is our horizontal distance. This is our horizontal distance. Okay, and this is our vertical distance. If we consider this is the bottom of the bed, bottom of the channel, so this is our vertical distance. So the slope is 1 vertical is equal to z horizontal. Then what will be the horizontal distance for y vertical? Okay, we have to think like that. What will be the horizontal when your vertical is y? Okay, if for one is z, for y it will be zy horizontal. Suppose now in our case, what is the slope is given? One horizontal is to three vertical. In this question, it's given one horizontal, that is one horizontal is equal to three vertical. Okay, so we all know one vertical is equal to z horizontal. Okay, and y vertical is equal to z multiplied by y horizontal. Okay, so definitely we can also write in a reverse way. Three vertical is equal to one horizontal. Okay, so one vertical is equal to 1 by 3 horizontal. Okay, so we will get this thing. Okay, one vertical equal to z horizontal. So in our case, our z is equal to 1 by 3. Okay, in our case, if you compare both the equation here, this is your general expression and this is our present question. Okay, so if you see, our z value is nothing but 1 by 3 in this numerical. Okay, for this numerical, our z value is 1 by 3. Okay, so this distance is your zy. So z is 1 by 3 and y value is already known to us. It's given, that is your 2.4. So if you multiply this two, you will get this portion. Okay, you will get this portion. Okay, if you multiply these two, you will get this portion. In trapezoidal, if side slope for both the side is same, then this two portion is also same. Okay, if you find one, you need not to find the other one again. Okay, we just multiply the two. Okay, this is the bottom of the channel. So these things we have already find out. That is your 1 by 3 multiplied by 2.4. That is your zy is nothing but you will get 0.8 meter. Okay. So now our intention is to find out the top width. Okay. Top width will be this portion, that is 0.8. Then in middle we have width of the channel or bottom width of the channel, that is your b plus 0.8 again. Okay. This portion. So how much you are going to get? This is 8 meter, so it will be 9.6 our top width meter, 9.6 meter. Okay, so that is why in area equation we have 9.6 plus 8 divided by 2 multiplied by the vertical distance between the two lines. Okay, that is our y. So you will get the area is 21.12 meter square. Okay, so this is how you can find out the area of a trapezoidal channel. Okay, definitely to find out the discharge, in this question we need to find out discharge. Discharge is nothing but area into velocity, area multiplied by velocity. So area we have already calculated. Now we need to find out velocity. As Sage's constant is given, so we are going to use Sage's equation. R into S. Okay. So to find out R again, area by weighted perimeter. Okay. So area we have already calculated. Now the next thing we need to find out the weighted perimeter of a trapezoidal channel. Okay. So when we find out trapezoidal channel, weighted perimeter of a trapezoidal channel, we have to consider this side, then the bottom of the channel, and the side of the channel till the water level. Okay. This will be your weighted perimeter. Okay. So again, this portion is a right angle triangle. Okay. This portion is a right angle triangle where this length is given, that is 2.4 meter. This we have calculated 0.8 meter. Okay. And this we need to find out this portion. We need to find out. So we are going to use Pythagoras theorem to find out the side of the channel. Okay. Using the Pythagoras theorem. So that is why weighted perimeter we need to find out. Sorry, we have to add b. In addition, we have to take the both the side. Okay, and both the side will be same as other parameters are same. Okay, so that's why we have multiplied by 2, and then we have used Pythagoras theorem here, okay, for right angle triangle. Okay, square root of square of other two sides, that is 0.8 whole square plus 2.4 whole square. This thing you have, you know. Okay, we have already did lots of numericals related to Pythagoras theorem in your 10th or 9th standard. Okay, so using Pythagoras theorem we directly find out the weighted perimeter. Okay, once you calculate the weighted perimeter, find out the R value. R equal to A by P. Okay, and then you use Sedgwick's equation. Okay, R is nothing but A by P. Slope is already given 1 by 4,000. Okay, find out the velocity by using Sedgwick's equation. Sedgwick's constant is given. R is nothing but A by P, and rate slope is already given 1 by 4,000. Okay, see, you are getting the velocity same as 1 meter per second. Okay, and then you substitute in this equation and you can find out the discharge. Okay. Try to calculate and see you are getting the same value or not. You all are getting the same value, that is 21.23. Stephanie, you have any doubt? How much you got? So the answer will depend upon how much you got velocity. Okay, you can take approximately 1 also, or you can also take 1.005. Okay, and the final answer you can consider for 2 decimal point. Okay, today we end here. Okay, 19. See, if area you are getting 21.12, okay, and the velocity you are getting 1, then it cannot be 19. Okay, so Stephanie, you check once again. Okay, area if you are getting 21.12 and velocity we are getting more than 1, so it cannot be less than 21.12 that discharge because we are multiplying. Okay, so kindly you check again. Okay, okay, so today we end our class here. Tomorrow, so we don't, I didn't think we have class tomorrow. Okay, so day after tomorrow again we have class, so we will solve few more numericals related to this. Okay, for triangular shape. Okay, and more trapezoidal shape numericals. Okay, and if you have any doubts regarding this or this numerical, you can ask me now, or try to solve few numericals related to trapezoidal channel. Okay, so if you find any doubts, then you can ask me in the next class also. Okay,